right, in this screencast, we're going to continue looking at the atmosphere, but we're going to be focusing on the fate of solar radiation coming to the planet. And then also we're going to dive into the physics of the greenhouse effect. So you need to be able to outline the role of the albedo effect from clouds in regulating global average temperature. I would also say you should probably be able to track the amount of radiation coming into the atmosphere and how, what is the fate of it. And then you need to be able to describe the greenhouse effect. So, and how does that regulate temperature on Earth? All right, first of all, this is an important diagram. You need to be able to talk about what happens to the light that comes in. Essentially, the light that's coming in, about 50% of it is going to be either reflected or absorbed by, the atmosphere. Okay, and about half of it, 51%, is actually going to be absorbed by the Earth. Some of that will be reflected by this, off the surface of the Earth. All right, so we have a reflection off the clouds, which I'm going to look at in a little bit more detail. So a lot of that incoming solar radiation is going to be just reflected back out to space by the clouds. So the clouds will absorb some is just going to get scattered in the atmosphere. But essentially what's coming in from, we tend to get UV light, visible light is what's, reaching the Earth. Most of the infrared heat that is released by the sun, because it's that whole gamut of electromagnetic spectrum, that is mostly going to be absorbed by the atmosphere, by the greenhouse gases already in the atmosphere. But what's going to come down is that UV light. All right. Now, I said I was going to talk about these clouds moving me around. So clouds actually help regulate our global average temperature because they can actually reflect a lot of that light coming in from the sun, a lot of the sun's radiation. And that we would talk about that in the role that albedo has. So albedo is how reflective a surface is to radiation. Like a mirror would be a perfect high albedo, right? Whereas snow also has a very high albedo. It reflects a lot of the light, the sun's radiation back out to space. Well, clouds actually have a pretty high albedo as well, so they can reflect a lot of that sun radiation. That's why when it's a cloudy day, it feels cooler than if it's a sunny day, because they're going to be reflecting a lot of that heat back out to space. So clouds are a very important aspect in regulating temperature on the planet. All right, now let's look at the greenhouse effect. It's very important that you get to know this greenhouse effect and how it works. And there's going to be some detailed vocabulary I'm going to bring up along the way. First of all, solar radiation from the sun, heading towards the Earth. Most of it that's going to come and reach the Earth is going to be shortwave radiation. So you should probably put that down. Shortwave radiation. A lot of it's ultraviolet, but shortwave radiation is coming through the atmosphere and it's going to warm up the Earth. The Earth is actually going to absorb that shortwave radiation. That warms it up. And then as it actually gets converted to infrared radiation, so a long wave radiation, as it's being released as heat. So it is radiating from the Earth as heat. You can see over here. And that heat is technically long wave radiation, or also known as infrared radiation. Okay, so it comes in through the atmosphere as shortwave radiation, gets absorbed by the Earth. Okay, and then it's re-radiated as long wave or infrared radiation back out to the atmosphere. Now, some of that will make it all the way back out to space. But the atmosphere has greenhouse gases in it, carbon dioxide, methane, nitrous oxides, that will actually absorb the infrared radiation. They have this resonance frequency that allows it to catch that perfect wavelength, and it will absorb it and then re-radiate it in all directions. So instead of all of that infrared going out to space, a lot of that gets caught here and re-radiated by the greenhouse gases. Some will be radiated out to space, but a lot of that will be re-radiated back to planet Earth. And that actually allows us to have a pretty habitable temperature on the planet. It would be probably 20 degrees cooler without that.